Since the dawn of civilization, humanity has looked up at the night sky and asked the same question. Are we alone? For thousands of years, that question remained a matter of philosophy, imagination, and belief. Ancient civilizations created stories about the stars. Scientists later built telescopes that revealed planets, galaxies, and nebulae beyond anything previously imagined. But today, for the first time in human history, we possess a machine capable of examining distant worlds in extraordinary detail. A machine designed not only to observe the universe but to search for clues that life may exist beyond Earth. That machine is the James Webb Space Telescope. Launched in December 2021 after decades of planning and development, the James Webb Space Telescope is the most powerful space observatory ever constructed. Its golden mirror stretches more than 6 meters across and consists of 18 precisely aligned segments working together as a single giant eye. Positioned nearly 1 million miles from Earth at a gravitational balance point known as Lagrange point 2, Webb operates in a region of space where it can maintain a stable environment while continuously observing the cosmos. Unlike traditional telescopes that focus primarily on visible light, Webb specializes in infrared astronomy. This allows it to see through clouds of cosmic dust, study objects hidden from ordinary telescopes, and detect faint signals that have traveled across billions of light years. In many ways, Webb is not simply looking farther into space. It is looking back in time. Because light takes time to travel, every observation reveals a chapter from the universe's past. Some of the galaxies Webb studies emitted their light when the universe was only a few 100 million years old. These ancient signals are helping scientists understand how the first galaxies formed, how stars were born, and how the cosmos evolved into the universe we see today. Yet one of Webb's most exciting missions involves something much closer to home: the search for alien worlds. Just a few decades ago, scientists knew of only one planetary system, the one surrounding our Sun. Today, that picture has changed dramatically. Astronomers have discovered more than 5,000 confirmed exoplanets orbiting distant stars throughout our galaxy. Some are scorching worlds where temperatures can melt metal. Others are giant gas planets larger than Jupiter. A few appear to be rocky planets similar in size to Earth. And among these thousands of discoveries, some occupy a very special region known as the habitable zone. This is the distance from a star where temperatures may allow liquid water to exist on a planet's surface. Water is one of the most important ingredients for life as we know it. Without it, biology on Earth would not exist. Finding planets within this zone does not guarantee the presence of life, but it makes them particularly interesting targets for further study. One of the most famous examples is Proxima Centauri b. Orbiting the closest star to our solar system, Proxima Centauri b lies approximately 4.2 light-years away. Although that distance would take modern spacecraft tens of thousands of years to travel, it remains our nearest known potentially habitable exoplanet. Scientists believe the planet is slightly larger than Earth and receives enough energy from its star to potentially support liquid water. However, many mysteries remain. Does it possess a thick atmosphere? Could oceans exist on its surface? Or is it a barren world exposed to intense stellar radiation? These are exactly the kinds of questions Webb was built to investigate. But how can a telescope study a planet that appears as nothing more than a tiny point of light? The answer lies in one of the most sophisticated techniques in modern astronomy: spectroscopy. Whenever light passes through a planet's atmosphere, certain wavelengths are absorbed by gases present in that atmosphere. Each gas leaves behind a unique pattern, like a fingerprint. By examining these fingerprints, scientists can identify the chemical composition of distant worlds. Imagine observing a planet hundreds of trillions of miles away and determining whether its atmosphere contains water vapor, carbon dioxide, methane, or other important molecules. Just a generation ago, such capabilities would have seemed impossible. Today, James Webb performs this task routinely. Since beginning scientific operations, Webb has analyzed the atmospheres of numerous exoplanets. The telescope has detected water vapor in distant worlds, measured carbon dioxide with unprecedented precision, and observed atmospheric conditions unlike anything found in our own solar system. Every discovery adds another piece to the puzzle. The ultimate goal is to identify biosignatures. Biosignatures are chemical indicators that could suggest the presence of life. On Earth, living organisms constantly alter the atmosphere. Plants release oxygen. Microorganisms produce methane. Complex biological processes create chemical imbalances that would not naturally persist without life. If similar patterns were discovered on another planet, they could provide compelling evidence that biology exists elsewhere in the universe. However, scientists remain extremely cautious. Extraordinary claims require extraordinary evidence. Many gases associated with life can also be produced through non-biological processes. Volcanic activity, chemical reactions, and geological events can generate signals that mimic potential biosignatures. This is why researchers seek multiple independent lines of evidence before drawing conclusions. Finding life beyond Earth is not simply about detecting one molecule. It requires building a complete picture of a planet's environment. Temperature, atmospheric pressure, chemical composition, cloud coverage, surface conditions. All of these factors must be considered together. Fortunately, Webb is helping scientists do exactly that. The telescope's remarkable sensitivity allows researchers to study planets in greater detail than ever before. And what they are learning is reshaping our understanding of where life might exist. For many years, scientists focused primarily on planets that closely resembled Earth. Today, that perspective has expanded. Here on Earth, researchers have discovered life thriving in some of the most extreme environments imaginable. Certain microorganisms survive near deep-sea hydrothermal vents where temperatures exceed hundreds of degrees. Others flourish in highly acidic lakes. Some live beneath Antarctic ice sheets. Others survive in deserts receiving almost no rainfall. These organisms, known as extremophiles, have demonstrated that life is far more adaptable than previously believed. As a result, astronomers now consider a much wider variety of environments when searching for habitable worlds. Life may not require conditions identical to Earth. It may emerge in forms and locations we have yet to imagine. Another exciting target for Webb is the TRAPPIST-1 system. Located about 40 light-years away, this remarkable planetary system contains 7 rocky planets orbiting a small red dwarf star. At least 3 of these planets appear to reside within the habitable zone. Because the planets regularly pass in front of their star from our perspective, they provide excellent opportunities for atmospheric analysis. Scientists hope Webb's observations will reveal whether these worlds possess atmospheres and, if so, what those atmospheres contain. The answers could transform our understanding of planetary habitability. Beyond exoplanets, Webb continues making discoveries across the universe. Its observations have revealed unexpectedly mature galaxies in the early cosmos, challenging long-standing theories about galaxy formation. It has examined stellar nurseries where new suns are being born. It has studied black holes, planetary systems, and the chemical building blocks of life scattered throughout space. With every observation, new mysteries emerge. Questions that once seemed impossible to investigate are now becoming scientific research projects. The search for life is entering a new era. Future telescopes will build upon Webb's achievements. Engineers are already designing observatories capable of directly imaging Earth-like planets around nearby stars. These instruments may one day detect continents, oceans, weather systems, and perhaps even signs of technological civilizations. Imagine identifying artificial chemicals in a distant atmosphere, or detecting unusual patterns of light that cannot be explained by natural processes. While such discoveries remain speculative, they are no longer beyond the realm of scientific possibility. The foundation for that future is being built today, and James Webb stands at the center of it. Every day, the telescope gathers data from regions of space humanity has never explored. Every observation expands our understanding of the cosmos. Every new discovery reminds us that the universe is far larger, more complex, and more fascinating than we once believed. Somewhere among the hundreds of billions of stars in the Milky Way, there may be countless worlds waiting to be discovered. Worlds with oceans. Worlds with clouds. Worlds with ecosystems unlike anything on Earth. Perhaps even worlds where intelligent beings look toward their own night sky and wonder if they are alone. For now, we do not know the answer. But thanks to the James Webb Space Telescope, humanity has begun the most ambitious search in history. A search that stretches across light years. A search that reaches back billions of years into cosmic history. And a search that may eventually reveal one of the greatest discoveries of all time. That life is not unique to Earth. And that somewhere in the vast darkness of space, we have neighbors waiting to be found.